Hello class, this is part 2 of the toxin unit remediation packet. We're going to take a look at part 3, section 3, and section 4. So if you turn to the back of the first page in your packet, we're going to run down through questions 6, 7, 8, and 9. 6, 7, 8, and 9. Alright, so we had a new type of calculation here. How do you calculate how much a mole of something weighs if there are more than one element present? Alright, so we have an example that I ran you through here. If you calculate how much 1 mole of sulfuric acid weighs, the formula for sulfuric acid is H2SO4. There's 2 hydrogens, there's 1 sulfur, there's 4 oxygens. So you have to take into account how many of each are there, multiply it by how much a mole of each element weighs, and then add them all together. So if you haven't looked over that yet, read through that right now, put this on pause, look over that example, and then come back and take a look at me with question 6. Alright, question 6. I want to figure out how much 1 mole, 602 sextillion of calcium bromides would weigh. 1 calcium and 2 bromines. So I taught you in class to make a list vertically of how many of each element you have present. So I have 1 calcium and I have 2 bromines. I need to multiply each by how much a mole of each weighs. So calcium according to the periodic table is 40.08 grams for every mole. I have 1 mole, I multiply that, it's 40.08 grams. I then turn my attention to bromine. Bromine is number 35. Each bromine weighs 79.90 grams. I have 2 of them. 2 times 79.9 is 159.80 grams. So I add up my parts. And I find out how much a mole of this weighs. 199.88 grams per mole of my substance, calcium bromide. So that is my answer. So for every 602 sextillion of these, it weighs 199.88 grams. Let's take a look at number 7. Another example here, number 7. Calculate the molar mass of glucose. Glucose, 6 carbons, 12 hydrogens, 6 oxygens. I list my elements vertically. Put a little dash there. I then write down how many I have of each. 6 carbons, 12 hydrogens, 6 oxygens. I then multiply how many I have of each by how much a mole of each weighs. Carbon number 6 in the periodic table weighs 12.01 grams each. I have 6 of them. 6 times 12.01 is 72.06 grams. Hydrogen, I have 12 of them. Each mole is 1.01 grams. So 12 times that is equal to 12.12 grams. Oxygen, an even 16 grams per mole. I have 6 moles. So 6 times 16 is 96 grams. So I have to add up all 3 of my parts, my carbons, my hydrogens, and oxygens, put them together, and I find out the molar mass for glucose. Alright, there it is. There's my answer. 180.18 grams per mole. Alright, so now you know how to calculate the mole of any single substance on the periodic table, compound or element. Now we might want to break this down. Let's try to break this down. And we're actually going to do number 9 before we do number 8. So we want to break this down. Well, if 72 grams out of 180 grams of glucose is carbon, well, what percent of glucose is actually carbon? So this is a new type of problem called percent composition. So we'll start with number 9 since we just talked about glucose, and we'll go backwards. So if I want to figure out the percent composition, I need to figure out the part that I'm concerned about, the element that I'm concerned about. I divide it by the whole substance, the whole molar mass, and then I multiply by 100 to figure out what percent that substance makes up that other whole compound. Alright, so let's take a look here. So we have the whole, we calculated that the whole glucose the whole thing weighs 180.18 grams per mole. How did we get that? Let's take a look at number 7. This is how we got it. So now we're going to take the part that is carbon and divide it by the whole. So 72.06 grams is carbon. Let me use a different color here. 72.06 grams of carbon. I divide that by the whole entire substance, the molar mass of that. Times it by 100. And I find out that carbon makes up 39.99% of glucose's mass. Let's take a look at the second part, hydrogen. Hydrogen is 12.12 grams. The whole thing, as we just mentioned, is 180.18 grams. Times it by 100 after I divide it, and I find out my hydrogen makes up 6.73%. That's my second answer. So far, carbon is 39.99%, hydrogen 6.73%. I just need to do oxygen. Let me go back and refresh my memory. How much of our substance is oxygen? 96 grams of glucose is oxygen. So 96 grams divided by the whole. Multiply by 100, convert to percent, and I find it's 53.28% oxygen. So if I add up my 3%, 53.28 plus 6.73 plus 39.99, they add up to 100%. That makes sense. All the parts of a substance should equal 100%. We're going to do one more. This one's a little simpler, so if you had troubles following along with number 9, I'll take a look at number 8. Carbon dioxide, CO2. First step, anytime you do one of these, you want to figure out the molar mass. We haven't done this one yet, so we have to calculate the molar mass of CO2. I have 1 carbon, I have 2 oxygens. I look at my periodic table. Carbon is 12.01 grams per mole. I have 1 of it, I have 1 mole, so it's going to weigh 12.01 grams. I have 2 oxygens in every mole of CO2. 2 moles times 16 grams per mole tells me that my oxygens are going to weigh 32 grams. Those are my 2 parts. Add them up to figure out how much the whole substance weighs per mole. And I find out the whole thing weighs 44.01 grams. So now I'm going to take the carbon part divided by the whole, then I'm going to take the oxygen part divided by the whole, multiply both by 100 to figure out what percent is carbon, what percent is oxygen. So let's go ahead and do that. First, carbon is 12.01 grams. The whole carbon dioxide gas is 44.1 grams. Part divided by the whole, times by 100. And I find that my carbon makes up 27.29%. Second calculation, my oxygens. My oxygens weigh 32 grams. My whole substance, my carbon dioxide gas, weighs 44.01. Times it by 100. Find out that my oxygens make up 72.71%. Add up this plus this to check. Those 2 things add up to 100%, so I know my answers are correct if I have the correct molar mass. This is part 2 of your tutorial for remediating lessons 8 through 11 on toxins. Check out parts 3 and 4 if you're still having troubles with the mass to mole calculations. Have a great day.